Alright, today we're talking about solving equations with radicals in them. This is a very simple example. The step is to get the radical by itself, which it already is in this case. The square root is by itself on the left-hand side. And in order to remove a square root, you all know how to do that. You just got to square both sides. Alright, so I square this, and that'll get me 2n plus 1 is equal to 9. Now this is an extremely easy equation to solve. We solved them 100 times. 8 is equal to 2n, therefore n is equal to 4. Now there is one additional piece of information that we need to know on equations with radicals is the possibility of extraneous solutions. So we're going to have to check to make sure that this number, n equals 4, actually works in the original equation. When we plug it in, and nobody likes to plug it in, but we got to do it or else we might not realize that it's extraneous. 2 times 4 plus 1 is equal to 3. If this does not get the same value on the left-hand side and the right-hand side, then this equation does not work, and therefore 4 would be extraneous. Square root of 2 times 4 is 8, plus 1 equals 3. 8 plus 1 is 9. Square root of 9 equals 3. 3 equals 3. Yes, it does work. So that 4 is my answer. It's not extraneous. It doesn't take long to check them. This one has 2 square roots on it, but it is not any more difficult than any of the other problems because it's got the square roots by themselves on both sides. All we can have to do is square both sides of the equation. That'll get me a new equation without the square roots. X over 3 is equal to 3x minus 72. This is a complicated looking equation because of that division, but really it's not that hard to solve. Multiply both sides by 3, and that'll cancel. X is equal to, this was now 9x minus 3 times 72 is 216. This is an equation that we've solved 100 times. We can subtract the 9x from both sides and get negative 8x equals negative 216. And when we divide both sides by the negative 8, negative 216 divided by negative 8 is equal to 27. So x is equal to 27. Now, 27 may be extraneous in this case. It may not be. I don't really know, so I'm going to have to check it. I'm going to plug it back in for x on both sides of the equation because they have an x on both sides. So square root of 27 over 3 should be equal to the square root of 3 times 27 minus 72. Well, 27 over 3 is equal to 9, so the square root of 9 is actually equal to 3. We have a 3 on the left-hand side. Now, on the right-hand side, 3 times 27, that is going to be 81. So this says the square root of 81 minus 72. 81 minus 72 is equal to square root of 9, and so therefore 3 is equal to 3. So yes, that does work. We don't have to worry about an extraneous solution in this case. It does become more complicated when we start having square roots on one side and other things on the other side, like variables. You have to square both sides once the square root is by itself. Not a hard thing to start with. The square root of 2 minus n squared is just simply 2 minus n is equal to n squared is n squared. Now this is a quadratic equation, and quadratic ones are the ones that most commonly give you your extraneous solutions. We're going to have to solve this like we solve all the quadratic equations we've ever done. I'm going to go ahead and add n and subtract 2 from both sides, and that'll get me 0 is equal to n squared plus n minus 2. Now this is a quadratic equation now in standard form. We can solve it by either factoring or the quadratic formula or even completing the square, but it's a pretty easy one to factor. Two numbers that multiply to the negative 2 that will add to the positive 1 that are in the middle are going to be positive 2 and negative 1. So using the shortcut, this is going to be n plus 2 times n minus 1, and my solutions therefore are n is equal to negative 2 and a positive 1. Now, we have to check both of these answers to see if they're extraneous. When I plug in, let's start with the 1 because that's usually the simplest. I'm going to plug in 1 for n in both sides. Square root of 2 minus 1 is equal to 1. Well, square root of 2 minus 1 is 1 equals 1. 1 equals 1. Good. 1 works. Now what we have to do is check by plugging in the negative 2. So negative 2 is going to come in here on both sides of the equation, and we're going to say the square root of negative 2 minus 1 is equal to negative 2. Negative 2 minus 1 is the square root of negative 3 is equal to negative 2. Well, I think you can see here that the square root of negative 3 is I root 3, which is not equal to a negative 2. So this does not work. Therefore, negative 2 is extraneous, and n equals 1 is my solution. Most commonly, the extraneous solutions are the negative ones. However, negative answers are perfectly acceptable if they work on both sides of the original equation. It really just depends on your equation. This one is a more complicated equation because it doesn't just have a variable involved, but it also has this other number here. Remember, we first have to get the square root by itself, so I'm going to subtract 2 from both sides. K minus 2 is equal to the square root of 39 minus 2k. I will then need to solve this equation by squaring both sides of it. When I square both sides, the left side is actually a binomial squared. Now this is not k squared minus 4. I can't just square both numbers. I actually have to multiply all that out. So you can say k minus 2 squared is really k minus 2 times itself. And off to the side, you can FOIL it if you want to. This is going to be k squared minus 4k plus 4 as my FOILed out answer. So k squared minus 4k plus 4 is equal to, the right side is really easy, 39 minus 2k. Again, we have a quadratic equation. We want to get it in standard form. I'm going to go ahead and add 2k to both sides and subtract 39 from both sides. This will get me k squared. Negative 4 plus 2 is negative 2k. 4 minus 39 is negative 35 equals 0. This is again a very simple quadratic equation to do. Negative 35 that adds to the negative 2 in the middle are going to be 5 and 7. The 7 has to be the negative 1 to make the negative 2. I can again use the shortcut. This is going to be k plus 5 times k minus 7 is equal to 0. Now this gives me two answers. My answers are going to be k is equal to either negative 5 or positive 7. Now again, we have to check to see if either one of those is going to be an extraneous solution. You could see, though, that since the original equation has k by itself on the right side, it's not likely that negative 5 is going to be the right answer, because it's going to be hard to get a negative 5 whenever I take 2 and I add a square root to it, because it's going to be very hard to get a negative number out of this part. I'm very suspicious about the negative 5. Negative 5 is equal to 2 plus the square root of 39 minus 2 times negative 5. Now, 2 times negative 5 is 10, right? Positive 10 now. This says negative 5 equals 2 plus the square root of 39 plus 10 is 49. And this is going to be negative 5 is equal to 2 plus 7. Negative 5 is definitely not equal to 9, so that number is extraneous. I think we will find out that 7 will work out just fine, but you should always test just to make sure. We're going to plug it in for k on both the left and the right. So this is going to be 7 is equal to 2 plus square root of 39 minus 2 times 7. And this is going to be 7 is equal to 2 plus the square root of 2 times 7 is 14. 39 minus 14 is 25. And then therefore 7 is equal to 2 plus, and square root of 25 is 5. 2 plus 5 is 7, so that works out just fine. My final answer, k is equal to 7. Now again, just because the negative one happened to be the wrong one in the last two examples does not mean negative numbers cannot work in these equations. They can, depending on the equation and how it is set up. It is just most common in these types of problems that the negative number is the extraneous solution, if there is one.